So when we did lesson 6, we were finding a line of best fit by picking 2 points and coming up with the slope and writing the equation. If you would pick 2 different points, you'd come up with a slightly different equation, and the same thing when you pick different combinations of points, you're going to get different answers. Well, what we're going to do today is we're going to have the calculator find the line of best fit using all of the points. So the first couple of slides here, I'm going to just kind of scroll through them. So if you need to read them a little bit, you hit pause in the video, or you can go look at the notes that are on Canvas. Excuse me. This goes through the steps of how to put stuff in. So it's all here for you of how to create a scatter plot and all of that. That'll be in here. So again, where to plug stuff in, what to hit on the calculator to draw the actual scatter plot, how to come up with a linear regression. So all of those things are here. I'm going to run through them, but if you need them, they're in the notes, or you can, again, hit pause on the video here to be able to come up with what those are. Here's how to graph it if you need that. Okay, I went through this in section 6 about positive correlation, negative correlation. The calculator is actually going to spit that out at us, whether you have it draw the graph for you or not. All right, so let's talk about linear and nonlinear relationships. Just because something is drawn in a linear or nonlinear pattern doesn't mean, so if it's nonlinear, doesn't mean that there won't be a pattern. It's just not going to be linear, and that's something we'll talk about in later chapters. Okay, so I'm going to create a scatter plot and see if it's linear or not linear. So here's how you would do it in a calculator. You would go, let's get that so we can see it there. Stat, edit. If there's anything in there, you need to clear it out. We do need these to be L1 and L2. So if your calculator, and notice I'm hitting clear, not delete. So if your calculator does not say L1 or L2, then talk to me and I will show you how to do that. So we're going to plug the X's into L1 and the Y's into L2. So I'm going to do that here. If you want to get your calculator and do the same thing, if you don't have your calculator in front of you, why don't you hit pause and grab it. You're not going to do this wrong unless you type in a wrong number. So be careful typing it in, and when you're finished, I would double check, make sure all your numbers are right, and make sure you have the same number of numbers in L1 as you do in L2. Okay? So looks like everything's good there. I would then do, go to y equals, second and y equals. I want plot 1 turned on. Let's go to that. Mine is on. And I do want this first one highlighted here. I'm going to go back to y equals. I have stuff in here. If you do too, you're going to want to clear that out. Then I'm going to do zoom stat. Okay? So there would be the points. That's pretty linear. Okay? Now I know this point right here is a little bit off, but you could draw a line almost through all of those. So I would say yes, this would be a pretty close to a linear relationship. If I were to take and plug the second one in, I actually have the picture drawn down here. So that was the first one. This is the second one. This one's not quite so much. This one goes up, kind of goes straight over here, then goes up even faster. I would say that this one's not linear. This one actually would be more of a cubic equation. Again, we're just deciding whether it's linear or nonlinear. You could maybe argue that it's close enough to linear. You take, these 2 points here and move them over a little bit, and the rest of them would be fine. I would say nonlinear to that one. Okay. Last thing. This was the problem from section 6 here. I want to use the calculator to draw the scatter diagram, so let's go through that again. Let's clear this out. Stat, edit. Let's get these things out of here. if you don't want to watch me type all these things in, fast forward through the video for a minute or so. I don't know how long it's going to take me to do it. Sit here and tell you a joke maybe or something along the way. Let's see, I made a couple of mistakes already here. So that was 32.4, that was 32.7. You go a little slower here on the computer. It can't do stuff faster. It doesn't register. Hopefully you're doing this while I'm doing it too. Okay, there's the first one. I'm finished. I will go through and double check my numbers. Make sure they match up. Okay, so it looks like all my numbers there are okay. I think I'm good. All right, scatter diagram. So stat plot's already turned on. I don't have to worry about that, but if it wasn't, again, second y equals and turned it on. I'm going to do zoom and stat for number 9. There's my points. Okay. Not great. There is a positive relationship we see as we go over to the right with on-base percentage that the run scores do go up, but they're kind of scattered all over the place. So you could probably make an argument either way on this one. I would say it's, does there appear to be a relationship? Yes. As you go farther right, you do go up for the most part. Is it a great relationship? I would probably say no to that. So if it asked you to describe that more, then that's how I would describe it. Okay, to do the line of best fit, go to stat, arrow over to calc, and you can either use number 4 or number 8. Well, I'm going to use number 4. They're both linear. Number 8's used more in statistics. Second semester, we'll talk about that a little bit more. I'm just going to use number 4. This should say L1. This should say L2. This should be blank. So if there's anything there, then you need to get that out of there. If you don't see this menu, talk to me and I will show you on your calculator how to do it, because you have to tell it something different. And then I'm going to go down to calculate, and I get this. Okay, so we would have 49.19x, if I'm going to round 2 decimal places, minus 870.94. Okay, and I'll write that down in a second. Notice that we have this R1 and R2. I'm sorry. We have this R and R squared, not R1 and R2. If you don't have that on there, second catalog, I'm going to arrow down until I get to diagnostics. You want diagnostics on like that. And then when you do this regression, it'll be there. Okay? So I'm going to write the answer down here. So we've got, I just lost it, y. Oops. Y is equal to 49.19. It's terrible for, sorry. X minus 870.94. Okay, that would be the equation. Then, for the last question, use that line to predict the number of runs a team will score if their on-base percentage is 34.1. So make sure you're plugging this in the right spot. On-base percentage is X, number of runs is Y. So I'm given on-base percentage, so I'm going to plug in 34.1 for X. So I will have Y is equal to 49.19 times 34.1 minus 870.94. Let's plug that into the calculator. 49.19 times 4.1 minus 870.994. So we get 806.43. So I would do regular rounding with this, or it's going to be somewhere between 800, around 806 to 807 runs. But I would say 806 for an answer. Okay, that's how you use your TI-84 to do linear regression.